So again, today, solving rational equations. Really, the thing that changes today is our first step, and that is we want to factor our denominators first. And then the rest is kind of the same. Find the least common denominator, state your restricted values, multiply each term by that LCD, write it in standard form and solve, and then again, check for extraneous solutions. So step number one, we want to factor our denominators. So our first equation, we've got 3 over b squared minus b plus 1 over b equals 1 over b squared minus b. So again, that first step, we want to factor our denominators. In this case, this one's already factored, but the b squared minus b, what can we do to factor that? Right, we can take out the GCF, that b, so that's going to leave us with b times b minus 1. So then what is our least common denominator? If we're looking at these three things, we have b, and we also need to have that b minus 1. So our least common denominator is that combination, right? All of these have a b, but then we also have that b minus 1, so I need to have all of that included for our LCD. And then what are our restricted values? What values of b get us 0 in the denominator? 0 and 1, right? If we plug in 1 for b, 1 minus 1 would get us 0 in the denominator, and we can't have that. So now that we know what our LCD is, we can then take this value and multiply it across all of our terms. I'm going to take b minus 1, and multiply each and every single term by that value. And in doing so, that then eliminates our denominators, right? So in this case, our denominator fully cancels out what we're multiplying by, and we're left with just the numerator. So we just have 3 left over, plus, in this case, only the b cancels out. So that means our numerator is going to be multiplied by that b minus 1. So b minus 1 times 1, or anything multiplied by 1 is just itself. So we have plus b minus 1 equals, again, everything's going to cancel out. So we're left with just our numerator, which was a 1 in this case. So then now we're left with a much easier equation to work with. We want to solve for b, so I'm going to move my constants to the other side of the equation. So I can keep that at 3 minus 1. It's going to leave me with a 2. On this side, I want to move it over, so I'm going to subtract 2 on both sides. So I'm going to get b equals 1 minus 2.
Where did 2 come from again?
3 minus 1 gives us 2, and then I subtract it over. So our answer is b equals negative 1. Bless you. And negative 1 is not one of our excluded values, so we're kind of good to go. So let's look at.
Wait,
Yes.
so if it ends up being one of those values, then what do you have to do?
Then it's extraneous solution. It's not going to work. So it's going to be kind of like one of those rare cases. In this case, negative 1 is not, so we're good. Okay. Let's check equation number 2. We've got 2 over b plus 2 minus 3 over b plus 2 equals 2 b minus 3. Okay. In this case, all of these are already factored, right? You can't do anything to simplify these denominators anymore. So then the next thing is, what is our least common denominator going to be? So b minus 3 and v plus 2, right? These are both unique, so I'm going to have to use them both in my least common denominator. So then what are our restricted values going to be? What can v not equal? Negative 2 and 3. So now we know our LCD is, we know what our restricted values are. We can multiply everything by that LCD. So v minus 3 and v plus 2. To all of our terms. And then we can multiply. So in this case, v plus 2's are going to cancel out on our first term, leaving us with a v minus 3 multiplied by our numerator. So that's going to get us 2v minus 6. And then we're subtracting our second term. The v plus 2 cancels again. This time we're multiplying everything by 3. I'm going to put it in parentheses. So we've got 3 times v, and then 3 times negative 3 gets us a negative 9. And again, we're subtracting this entire thing, so that's why I put it in parentheses. We'll distribute that in a second. Equals, that v minus 3 again cancels out. And this time we have v plus 2 multiplied by our numerator, so we get 2v plus 4. Then we want to solve. Okay, so I'm going to move my v's to the left side of the equation, so I'm going to subtract 2v over. Then I'll go ahead and add my 6 across. So I'm going to get my constants on the right side. So that cancels that out. So now I've got this negative that I need to distribute to this term here. So negative times 3v, negative 3v. Negative times a negative 9, positive 9, 4 plus 6 gets me 10. Subtract my 9 over. I get negative 3v equals 1. Divide by our negative 3, and we get v equals negative 1/3. Again, check, is this an extraneous solution? It's not one of our excluded values. Any questions? So let's do our very last one for our example. So we got x minus 2. Squared plus 2x. So again, first step is we want to factor. However, we don't really want to factor our numerators unless we know they can cancel out with one of the denominators, because then we're going to have to unfactor it to multiply if we have to change its value. So in this case, I know that's not going to factor into an x minus 1, and I know that's not going to factor into an x minus 1, so we'll just leave it alone. But we can factor this denominator. What does this denominator factor into? X plus, so we have x plus, x minus, x plus 3, minus 1. All right, 3 times 1, or negative 1 gets us that negative 3. 3 minus 1 gets us that 2. Okay. So that's this denominator. So then if we're looking at all of our denominators, what would be our least common denominator among the 3? X minus 1 and x plus 3. Right? We have to have each piece. What are our restricted values? What values of x can we not have?
1
1 and negative 3. Perfect. So the next thing, again, we're going to multiply everything by that LCD. This first term, of course, when we multiply by it, it's going to completely cancel out. It's just going to leave us with that x minus 2. Our second one, or our second term, when we multiply by it, the x minus 1s will cancel, so I'm really just going to multiply this second one by the x plus 3. So then that means we're going to have to FOIL. Now we've got two binomials. We've got x plus 3 times 2x plus 4. So x times 2x is 2x squared. X times 4 is 4x. 3 times 2x is 6x. And 3 times 4 is 12. Minus, and I'm going to do parentheses. Same kind of idea as the second term. That x minus 1 is going to cancel out. We'll multiply those two. And that leaves us with that x plus 3. We're then multiplying by our numerator. So x times 2x gives us 2x squared again. X times 6, 6x. 3 times 2x, another 6x. And 3 times 6 gives us 18. So then we want to combine our like terms. I'm going to combine the like terms on the right side first, just to see what we're doing. Now, don't forget, we're subtracting this entire piece. So I'm going to go ahead and just change our signs on all of these. So that's going to be a negative 2x squared minus 6x minus 6x minus 18. Okay. So that kind of just lops that part out. And then let's combine our like terms. So we've got a 2x squared minus a 2x squared. Those two things cancel each other out. I'm looking, I've got a 6x minus a 6x. Those two things cancel each other out. But let's combine the rest of our terms. We've got 4x minus 6x. Leave us with a negative 2x. So those are gone. And I've got a 12 minus an 18. Leave you with a negative 6. And I've combined everything that I can. And that's what I'm left with. On our left side, it's just that x minus 2. So then let's solve. I'm going to move my x's to one side, move my constants to the other. So add 2x over. Add 2 to my other side. So x plus 2x is going to give me a 3x. And negative 6 plus 2 is negative 4. Divide by our 3, we get x equals negative 4 thirds. Negative 4 thirds is not one of our excluded values. So that is our solution. Okay. Any questions on solving our rational equations? Again, we were doing this yesterday. We just didn't have expressions in the denominators, right? We just had those single terms. So we're just kind of doing one step up from what we were working on last time. So any questions? All right, so that takes you to today's homework.